Yeah, so thanks everybody for making the time coming out today for this seminar. So the goal here, what I'm going to try to do over the next hour is give you guys sort of two big things. So I'm trying to do one thing. I'm trying to tell you guys sort of about the underlying trade-offs that go into what makes Python different. So comparing Python to other tools, what makes it a good tool for the job versus a bad tool for the job. So the hope is that you can leave here today being able to recognize times when Python's a good idea or when using Python is not such a good idea. The second big goal for the seminar is to give you guys a quick introduction to sort of the essential tools in the Python data science toolset. So this way, if you hear about these tools at work, you can kind of understand what's going on and know what these tools enable. Okay, so that's sort of the goal here. So on the one hand, just getting clear on what Python is good for, what it's not good for. And then secondly, so like who are the main characters in the Python data science toolset. So we're going to be running this seminar a little bit differently than how a class would normally work. So for a class, we would have sort of a back and forth, lots of questions, answers, and then also about half of the time would be spent doing exercises. This seminar format's a little different. We have a lot of people tuning in today, so we can't have as much interactive class time, and we can't have as much sort of exercise time. But just know that this is sort of special to the seminar format and not sort of typical of how the classes work. Yeah, okay, so let's get started. So just one last note on the format. If you have any questions, please feel free to throw them in the group chat. I'll be checking in on the questions periodically, sort of try to answer them in batch at appropriate times during the seminar. Okay, so I will get started on the first task here, talking about what makes Python distinct. So one big feature of Python is that it's known for short readable code. So I'm going to focus first on this code part of it and just talk about the trade-offs there. So if you look at other tools like such as Excel or SPSS or Stata, these kind of tools have a lot of drop downs. They have buttons you can click. And these are unarguably easier for beginners to use, right? So the learning curve when you're starting out is much easier if you have a UI. The trade-off is that later it becomes harder to maintain complex projects. So code is sort of harder to use in the beginning, but I would argue it becomes easier for complex projects later on. So maybe I'll talk about that for a minute, like why I think that's the case. So one thing is taking the case of Excel, because Excel puts so much complexity into the visuals, into the buttons and cells, there's a lot of stuff that you can't see just by looking at an Excel sheet. You can't see the formulas that are generating the values in each of your cells. You can't see when cells are linked to other sheets or other columns. And this, in the long run, ends up being a source of major headaches and complexity. So to contrast, whenever you have any kind of change in a coding language like Python, those changes can be explicitly called out because everything's in text, right? Everything's in code. So you don't have this sort of hidden complexity underneath or behind the scenes. This also makes collaborating much, much easier. So if you have an Excel sheet that you're emailing back and forth, it's really hard to tell when someone has changed something, right? When you're dealing with code, you can see exactly which lines have been altered. So although Excel might be easier to start with because there's things you can click on, drop downs that you can select, in the long run, having everything written out in code explicitly can make things a lot simpler. I think one last benefit that I'd like to mention is that if you're used to Excel, you have the things you normally do by clicking through the application. If you have a routine that you normally click through in your application, automating that process later becomes difficult, right? You either have to write some Excel, you have to either record a macro or write some Visual Basic. In Python, it's like you get the automation for free. Since you've already written the code, you can just rerun the code and it's like you have a macro already. So if you're coming from an Excel background, I think that's one way of sort of stating the advantage of using Python. Okay. Okay, so that's focusing on the code portion of this. So code versus a visual UI. So what's the real trade-off here? When should you use Python versus when should you use a tool with a visual UI? Well, I think this is a good rule of thumb. If this is a project that's supposed to be quick, that you're just going to do and then throw away, I think doing something, if you can do it in a visual UI, then that's a great way to do it. Just get it done fast. If this is something that you're going to build up and use for a very long time, I think Python is better suited to that. It's going to be more maintainable and less of a bundle of knots in the long run. And then I think also you want to think about where's the ceiling in terms of what I can do. So in Excel, in a lot of these applications like SPSS, you're going to hit a ceiling in terms of, all right, it's been great, it's been easy up until I wanted to do something that this tool just can't do. So Python is able to do a lot more. It's much more flexible in terms of what its highest capabilities are. So if you think about Excel, unless somebody has designed a specific button for doing exactly what you want to do, it's a little hard to sort of bend the tool in the direction you need to go. With Python, it's a programming language, so the flexibility is much greater in terms of what you can build out of it. So yeah, this is the second consideration. So are you going to hit some sort of ceiling and be stuck there? Okay. All right, so moving away from the code portion of this, now I'm going to talk about the short and readable aspect of this. So when Python was developed in 1991, that was its first release, computers were much slower and more expensive than they are now. So the idea that Python's code would be short and readable at the expense of being faster for the computer to run was actually like a very controversial move at the time. So this is getting at kind of a deep computer science problem, which is the easier you make your code to read, or the easier you make your code to write for human beings, the more work the computer has to do to understand that code and run it. So Python has made a pretty decisive choice in this case, favoring human productivity over computer speed. And while that was a controversial move in the 90s, today computers are a lot faster, so this kind of trade-off makes a lot of sense. In the 90s, they still had a lot of people running mainframes where you'd have to sign up for a slot. You would have to say, okay, between 3 and 4 p.m., I want to run my program, and then you would bring your program and type it into the terminal, and that's, you know, we're a long ways from there. Okay, so yeah, human productivity over computer speed, and then also the short and readable comes into play when you talk about organizationally, how does Python work well? So I think we imagine, when we picture programmers, we imagine some guy in a dark room sort of hacking away on a laptop. But actually, most programmers work in teams. And when you're working in a team, you're reading code about 10 times more than you're writing it. They've actually done sociological studies on how programming teams work. And when you're working on a team, you have to go around and understand what everyone else's code is doing, as well as write your own code, right? It all has to fit together. And so what it means is that if you're a programmer working on any kind of team, the readability of your end product of your code is going to be a lot more important than just how fast you can put it out. Okay, so again, I want to emphasize the trade-off here. So what does this mean for when Python is a good tool versus when it's not a good tool? Python would be a great choice when you're looking at developing fast. So when you're looking to create something new and you want to be able to move quickly. Maybe it's not the best tool when you're talking about you want to achieve very rapid speeds, you want to be able to do high frequency trading, or if you need your application to have like NASA level reliability. So if you need your code to be as fast as a computer can possibly work, then probably not the tool for the job. Okay. So one of the last points I wanted to make about Python's sort of position in this space of data tools is, so Python is open source, has a broad open source community. So focusing on open source here, if open source is a new idea, I just want to reiterate. So open source means that Python's code, all the source code that goes into making Python run, is freely available on the internet. So I think when you tell this to people initially, I think there is kind of an initial reaction to this, to think, okay, if it's freely available, I don't have to pay for it. How can it possibly be? How can it be the best tool or the most valuable tool for the job? So the analogy in people's heads might be, if somebody gave you a car, a free car, I think you would be really suspicious about whether it's a good car or not. However, since we're talking about software, I think the analogy needs to be a little bit different. So how I would think about it is, instead, open source software is more like a well-trod path. So this is a road that's been used heavily, and so it's smoother and less problematic than some other tool you might use. So the fact that open source software is free, anybody can use it, means that you have a much larger community of users all over the world, which means everybody has a vested interest in making sure that this tool works really well. So people all over the world at this point contribute back to Python, either to the core language of Python or to packages, these add-ons to the language. So all hours of the day, there's people all over the world contributing back to Python, making it a better and better tool. So at this point, open source is a faster, more effective way of developing software than trying to hire a bunch of developers and keep them all under one roof and build software that you charge for. So this wasn't always the case. So in the 90s, when Python was first developed, if you wanted to use Python, you would have to mail a guy in the Netherlands. He would send you a stack of floppy disks, and you would install those one by one. So collaborating on open source software at that point was very difficult, and it wasn't really a winning strategy. At that point, the winning strategy was to hire really talented developers, put them all under one roof, and stamp Microsoft on whatever they wrote. However, nowadays, it's much easier with the internet to collaborate on open source software. People do it, like I said, every hour of every day. And so now open source tends to move a lot faster than any proprietary software can. You just can't hire enough software developers to keep up with the voluntary efforts that go on all over the world. Okay, so what does this mean as far as trade-offs for Python? So the downside is Python does not have a dedicated support department. You can't pick up the phone and call Python and ask them why your program isn't working. However, because so many people all over the world are using Python, it's very easy to get help, either just by Googling. I guarantee you, you're not going to be the first person to run into any bug you see. Either by Googling or reaching out to one of the many, many experts on Python, you can always get help. It's just, it's different than proprietary software in that there isn't sort of a help department that you can just call. Okay. Yeah, so this quote from Eric Raymond is kind of getting at why open source software is fundamentally a good idea. If we give more and more people this code, if more and more people are trying it out, we as a group are going to do a better job of rooting out all these little bugs. Okay, so that's sort of getting at open source, specifically within Python. So there are a lot of open source, there's a lot of open source languages, but just looking at Python now, Python has sort of a unique position in that it's an open source tool that is used for a lot of different things. So people use Python for web development, people use Python for data science, automation, InfoSec, and having all of that functionality in one language makes it really nice when you're collaborating within a team, across teams, what have you. So for example, in data science, having your data scientists be able to develop a model and then hand it to their programmers to be able to deploy that model all within Python, it really simplifies a lot of processes. They don't have to take MATLAB code and then rewrite it in Python or what have you. And I think I should emphasize, although Python is used for a lot of different things, the aspect of the language that's really exploding right now is the data science side. So I think 5-10 years ago, when Python was sort of a younger language, you would go to conferences and it would be mostly web development or automation or things like that. Now, going to a Python conference, it's almost 50-50 data science and everything else. So data science has really exploded within Python. So looking at the most popular languages or most popular packages, these are sort of add-ons for the Python language. You can see we have, so two of these, Django and Flask, those are the flat lines. So the flat lines represent packages that are used for web development inside Python. So the web development packages are pretty, well, maybe they're growing a little bit, but they're pretty flat. The packages that are really exploding, so pandas, NumPy, matplotlib, these are all data science packages. So when you hear about the rise of Python or the explosion of Python, what you should really be recognizing here is that it's pretty much all happening on the data science side. Okay, so the kind of final trade-off here that I wanted to sort of at least mention is, okay, so Python is really good for these things, for data science, for automation, for web development. This is a much broader set of use cases than you'll usually find with a given programming language. something like Swift is basically only dedicated to iOS app development. JavaScript is pretty focused on developing web pages at this point. So yes, it is a broad cross-section of use cases. I think I do have to acknowledge, or I think it wouldn't be useful unless I acknowledged things that Python is not an ideal tool for. So things that Python is not sort of a go-to tool for. So iOS app development, there are dedicated languages for that. And while Python might be able to do it, it's not really an ideal tool. It's not one of the focuses that this open source community has sort of honed in on. Another application that Python is probably not the right tool for would be so game development. So there are ways to make like 2D games, like arcade games in Python. But if you're trying to develop something 3D or something sort of more involved that you're going to put on the internet, you want people to be able to play it in a browser, Python doesn't really have good support for things like that. Let's see. And okay, we've already talked about high frequency trading. Anything that depends on speed, probably not a good fit for Python. Okay, so we've talked about several of the things that Python is a very good tool for, and some of the things that Python isn't so great at. Okay, so this kind of brings us to the end of my first section. The first section here was just dedicated to trying to give you a sense for when Python's a good tool to use and when it's probably not suited for the job. I think I'll pause for a second and just check the chat, see if we have. Oh, okay. So one question: can you answer what's the difference between data analytics and data science? Okay, so I don't know that there's a hard and fast rule here. I think when you hear data analysis, usually what people are talking about is exploratory data analysis. So people are trying to look at the data, find sort of summary statistics or visualizations that give them some rough idea of what's going on. I think when you look at data science, it's a little bit broader term. So data science would also include, say, machine learning, predictive modeling and machine learning, I guess I would put all on one side. And I think I would also put under data science some sort of more advanced algorithms. So if you're writing code that's going to sort of rely on mathematical techniques for simplifying your data, maybe reducing the number of dimensions that your data has, I think that would go beyond the scope of what you would normally consider in just data analysis. Yeah, so that's kind of how I would look at it. Usually in the job market, when you hear data analysis, it usually means you're going to be using a visual tool, so more like SPSS or Stata or Excel. When you hear about a data science job, I think usually it implies that you're going to be writing code. So that would be another way of slicing this up. When you hear data science, I think people are going to expect you to write code. When you are doing a data analyst job, it's often fine if all you're using is sort of GUI-based, graphical user interface based tools like Excel or Tableau or SPSS. Okay. So I think that's it for questions on the first half. Great. All right. So that brings us to the second half of the show, where we're going to be talking about the sort of main characters in Python's data science tool set. So here okay, the purpose of the first half, right, was to give you an idea of what Python's good for, but maybe it's not a good idea to use it for it. And then the second half, the idea is, okay, I want you guys to be able to recognize these main characters. So these main tools, when people bring them up, I want you to know what it is that they enable. So what's the advantage of using them? So that even if you don't have hands-on experience with it, you know, like what you need to go out and learn if you want to get a certain task done. Okay. All right. So I'll go through, I think we're going to cover, I believe we're covering 4 of these tools. So I'll go through a couple of them, show you guys some code, and then cover the last 2, show a little more code. Okay. So the first tool we're going to be looking at is Jupyter Notebooks. So a Jupyter Notebook is sort of the standard format for a data scientist to capture their work in. So first of all, the name Jupyter comes from combining the 3 biggest languages for data science. So Julia, Python, and R are sort of concatenated into the name Jupyter. So Jupyter Notebooks, what they allow you to do is they allow you to put your code, any data visualizations you're using, and also notes to explain your code all in one place. So that's the sort of the killer feature here, is that you can have explanations for your code right alongside your visualizations in your code. So this is sort of what a Jupyter Notebook is going to look like. It has these little cells. So these slightly darker regions with the code in them are called cells. You can execute your code in these cells to generate these visualizations. But you can also have text alongside your code to explain exactly what you're doing. So oftentimes when you're doing data analysis or you're creating a machine learning model, it's not clear from just the code why you're doing what it is you're doing. Or if you generate a visualization, it's not clear what you sort of learned from that visualization. So to guide someone through your thought process, it really helps to have these Jupyter Notebooks. On a sort of career side note, what I would say is if you're interested in applying for data science related jobs, so if you want to be working in data science or something like that, as a data scientist or something like that, these Jupyter Notebooks are really what I would use as your main portfolio items. So being able to show someone your Jupyter Notebook and sort of how you've thought through a problem, that would carry a lot of weight in the interview process. So it's good to know about sort of the standard formats, so people kind of take you seriously when you're applying to jobs. Okay. Okay. Yeah, I think I've covered sort of what I wanted to cover there. Yeah. So Jupyter, it allows you to capture your notes, your code, and your visualizations all in one place, and you can sort of work in these Jupyter Notebooks and just save your work at the end. So you can think about it sort of similar to it's sort of like the Microsoft Word or the Microsoft Excel of Python data science. Well, actually more than just Python data science, R or Julia as well. Okay, so that's sort of the first tool I wanted to introduce. I think I should mention this notebook format. I think it originated in Mathematica. So the idea of putting your notes and your visualizations all in one place, I think it originated in Mathematica and was sort of stolen and dropped into Python and then subsequently R and Julia. All right, so that's Jupyter Notebooks. Next up, we're going to talk about pandas. So it's a little bit of a sort of funny name, but it's actually short for panel data. So it comes from somebody working on quantitative finance, and they were chiefly interested in being able to use panel data inside Python. So pandas, in a sentence, is sort of Python's answer to the Excel spreadsheet. So we're going to have data captured in a sort of column by column format, and you're going to have sort of rows of data with all the same columns. So very, very similar to a spreadsheet. The data frame is the main so the main type of it's like the main container that we're going to use inside of pandas. This is like a spreadsheet inside of Excel, and that concept comes from the language R. So we've sort of stolen that that concept from R. Okay, so here, if I was looking at a data frame in Python, it might look something like this. So I might use this function or this method head to just look at the first few lines of a spreadsheet, and it would come out looking something like this. So here I'm looking at restaurant inspection data, and we have sort of whether they're located in Manhattan or Brooklyn, what their zip code is, what their phone number is, etc. So what does Python, or what does pandas enable, right? So we talked about Jupyter Notebooks, what that enables. What does pandas enable? So pandas, well, compared to Excel, pandas is much more memory efficient. So because I think largely it's not, it doesn't have to do as much visualization or as much visual UI work. So pandas can handle, even on an old laptop like mine, it can handle sort of low millions of rows, work very quickly with data that goes into the millions. And compared to sort of normal Python, it allows you to have the normal sort of column-oriented workflow that you would have in Excel. So if you have a bunch of data, you have you have revenue and you have expenses. You can create a new column of profit by subtracting the first column from the second column, right? So column A minus column B gives you column C. So pandas, finally, pandas has like a huge community behind it. So if you're worried about switching from a tool like Excel, which, yeah, I mean, Excel is definitely a well-worn path, pandas is at this point used by millions of people. So it's not like you're switching to a sort of obscure off the beaten path tool by using pandas. Okay, so these are all advantages, but like, what are the use cases here? So if you're in Python and you're doing exploratory data analysis, you're almost certainly using pandas. So pandas is the go-to tool for exploratory data analysis in Python. Cleaning data. So cleaning data in Python, again, you're probably going to be using pandas. This is the go-to tool. Pandas has a lot of functions and methods built in just specifically for the task of cleaning data. So it's sort of purpose-built to this end. And then finally, why you might reach for pandas. Pandas is built to be very fast. So you think about Python, what I said about Python originally, and how it favors human productivity over the speed of the machine. Well, pandas is actually built so that we can rely on faster languages when we need to. So when we need to be fast, we can sort of drop down into a lower level, more speedy language, and then take the results and jump back into normal Python. So this visualization kind of gets at what's going on here. So when we need to be really fast, when we're dealing with millions of lines of code, we can sort of drop down into these faster languages like C or C++. We can do the processing that needs to be fast, and then we can jump back into Python, which is easier to use. So this is something that Pandas and the packages that it's built on. So Pandas built on top of NumPy and packages like that. This is how we're able to be fast, even in a relatively slower language like Python. I think one thing I'd like to clarify when I bring this stuff up is that even though I say Python is slow, that's only in comparison to other programming languages. So older programming languages like C or C++ sort of favored computer speed because they had to be able to get things done in the sort of 70s and 80s. So when I say Python is slow compared to C or C++, that's definitely not saying that Python is slow compared to Adobe Photoshop or Excel or something like that. So compared to applications, computer applications like that, Python is still blazing fast. It's really only when you're comparing to sort of low-level computer programming languages like C or C++. Okay. Okay, so I have a couple more tools, but I don't want to just keep piling these on. So if there are any questions, I can take those now on just Pandas or Jupyter Notebooks. So I'm going to switch to, let me see if I can get out of my slideshow here. I'm going to switch to coding now. So I'm just going to show you guys a little bit about how this works in practice. So let me sort of hide the meeting panel here. Okay, so this is a Jupyter Notebook, like I talked about. So here we have some nicely formatted text, sort of explaining what I'm doing in my Jupyter Notebook. I have a visualization that I can embed, and then I can also have a cell here that I can use to execute my Python code. So you can make more cells. If I write some Python code here, I can actually execute it right in this notebook. So this is sort of the advantage of using a Jupyter Notebook, right? I have all my explanation alongside my code, and then also I have my code broken up into separate cells, so separate chunks. So this is really helpful for being able to sort of execute your program a piece at a time and see that each is working, instead of just having to execute everything all at once and not knowing sort of what's going wrong. So a lot of benefits for using a Jupyter Notebook. All right. I think the second thing I wanted to show you guys was just what some sort of Pandas code would look like. So here I'm importing Pandas. So we have Python, the core language, and that's sort of what everybody runs when they're using Python. But you also have what are called packages. These are like add-ons to the language. So Pandas or Matplotlib or any of these other packages, these are the add-ons. And the way that you tell Python that you want to use an add-on is with this import statement. So I'm saying, please import this add-on, Pandas, and please nickname it PD. So shorten it just for the sake of my code, please shorten it to PD. So with Pandas, I can read in an Excel spreadsheet like this. So here I have an Excel spreadsheet of data about everybody who was on the Titanic. So the famous wrecked ship, the Titanic. And this is sort of a classic data set that people will use to practice machine learning or exploratory data analysis, just because we have a lot of we have very accurate data about who was on the Titanic, how old they were, everything like that. So we can find some interesting things out. So here's an example of what we can do with pandas. So I can take one of these columns like age. So here I have an age column that tells me how old every passenger was. And I can say, okay, I just want to filter down to the people who are under 18. I'm going to make a new column called minor, where I see if where I just take note of whether the person's a minor or not. So now when I say, all right, show me DF minor, or actually what I'll do is I'll say, I just want to look at the age column and the minor column. So that way I can see, okay, we've got all these people, well, they're over 18, so that makes sense that they're not minors. What I'll do is I'll filter to just the minors now. So I can apply this new filter that I used, or that I kind of came up with, this new minor column. I'm just narrowing down to the people who are minors. Okay, so that's sort of an example of what you can do with pandas. There's a lot of sort of built-in functionality for things you might want to do. Like, okay, let's try and find the average age of people on the Titanic. So the average person on the Titanic was about 30. We can look at things like, let's say the embarked town, so where they embarked from, and let's do the value counts. So we'll see. Okay, so 644 rows represent passengers that came from Southampton. 168 rows came from Cherbourg, and Queenstown, there are 77 passengers. So pandas makes a lot of these these like quick data analyses very easy, right? So for instance, yeah, so here's another example of something that pandas makes easy. We could take a pivot table. So if you're used to using Excel and you like using pivot tables, it's very simple to take a column like survived, and we're going to split it up along where they embarked from, what class passenger they were, along the rows versus along the columns. And we get ourselves sort of a breakdown of survival rates, right? So first class passengers had a much better survival rate no matter where they came from. Well, actually, except for Queenstown. So it looks like Queenstown, second class passengers from Queenstown had a better time than first class passengers, probably because there weren't that many of them, 77, right? But this is like sort of an example of how pandas can replicate a lot of the sort of quick stuff that Excel lets you do. Okay. So I'm gonna check. Okay, so before I go into the last two tools in the Python tool set, I'm just checking for questions that got forwarded here. Okay, the difference between R and Python for data science, it's an interesting question. So R is definitely a very strong and legitimate language for doing data science. I think the difference lies in where each language came from. So they're actually about the same age. The main difference is that R was developed by statisticians for statisticians. So if you're trying to do work that's at all related to statistics, R is going to be using the same terminology that statisticians use. It's going to be probably up to date with the latest statistics work, and it has sort of the same perspective that statisticians have. So if you have a background in statistics, if that's where you're coming from, that's probably going to be an easier transition to make. However, Python, Python, instead of being developed by statisticians, Python was developed by programmers who were trying to get sort of more practical building tasks done. So they were trying to build programs quickly. And that sort of philosophy sort of shows up in what the languages are good for, right? So while R is very focused on being good for statistics, Python has a much wider range in terms of what you can do with it. So Python is very good for automation. It's very good for web development. It's good for data science. So if you don't know exactly what you want to do long term, I would always recommend Python, just because you give yourself more optionality down the road. So if you get into R and you decide, maybe statistics isn't my thing, it's kind of tough because you can't do a whole lot else with R at this moment. Whereas with Python, you have a lot of options still. Like you can still go into web development or any of these other areas. Final note is that Python is descended from the same programming languages. It's like sort of in the same programming language family as most of the major languages going around right now. So C#, C++, C, Java, these are all sort of in the same family, whereas R is sort of descended from these more obscure languages. It's almost as if you're talking about human languages, it's kind of like Python is descended from Latin. So it's like just in this family of Romantic languages, whereas R is more off on its own, sort of developed, maybe it's a descendant of Russian or some of these more distinct languages. So that's just, I guess, one more factor to consider. So if you're used to coding in C++ or C# or any of these other, like Java, Python's going to be a lot more intuitive. It's going to be a lot more similar to that, whereas R is based on functional languages, and so that's going to be just very different. If you have past programming experience, it's probably going to be a little weird. Okay. So, all right, got two more tools to introduce you to. First is Matplotlib. So Matplotlib is the go-to visualization library in Python. It was originally designed to replicate the visualization capabilities of MATLAB. So, I mean, Matplotlib goes back to the mid-90s, so it's a very sort of heavily used library. What's interesting is it's actually far surpassed what MATLAB can do in terms of visualization at this point in time. So this is just one example of how open source software has really surpassed proprietary software. So many people have contributed to Matplotlib that it's kind of caught up to and then subsequently surpassed MATLAB's capabilities. But it is by far Python's most popular graphing library. It's a bit older, so it isn't the easiest to use, but it is sort of the gold standard. So if you look at Matplotlib usage compared to all of the other leading visualization tools in Python, it's really not even close. So Matplotlib has a lot more usage. The way we're measuring usage here, and this is sort of an interesting trick that I think this is a good thing to know how to look up. So that where I'm getting these numbers is from the website Stack Overflow. So Stack Overflow is the biggest, I would say the only question and answer site that every programmer uses. So anytime a programmer has some sort of bug or problem they don't know how to solve, they're going to jump on Stack Overflow and post about it. And other programmers will hopefully help them out, answer, what's going wrong, how to fix it, all that. So what we're seeing here is how many questions and answers, how much activity there was on Stack Overflow about these different tools. So this is a really interesting source of information. You should go try it out sometime. If you're curious about what programming tool or language is getting more usage, you can actually just hop on there, and they make a lot of these. They make this data widely available, so you can just sort of look it up yourself. You could type in Java versus JavaScript and see how the usage rises and falls over the years. And it's a really interesting metric for what's going on out there in tech. Like, what are programmers using versus what do they say they're using? It's sort of it's very grounded data, so it's good to be able to look up. But anyway, the point of this is just that matplotlib is getting used way more than any Python visualization tool, any of the alternatives. And actually, if you compare it to entire other programming languages, so here the Haskell programming language it's sort of an elite tool that a lot of programmers talk about using. It's very rigid, very strict, and it's sort of a point of pride if you as a programmer are able to use it. However, if you actually look at the data, there are more people using matplotlib than, almost double. Actually more than double of the people, they're 2x the people using matplotlib than are actually using Haskell and answering questions or asking questions about it. So matplotlib, just being one package within Python, is actually getting a lot more usage than this other entire programming language. So it's kind of an interesting point of comparison. So here are some examples of what you're able to, so visualizations you're able to create in matplotlib. So the original purpose of matplotlib was to create, I think the phrase was publication-ready visualizations. So people who were trying to publish in scientific journals, things like that, they wanted to be able to make really high-quality visualizations. So any sort of highly detailed visualization you want to build, matplotlib is going to be able to build it. It might not be the easiest because matplotlib is a little bit of an older tool, but its capabilities are pretty endless. Okay, so that's sort of an example of visualization, of the visualization tool, matplotlib. Now, finally, we're going to move on to sort of machine learning capabilities with scikit learn. I'm just going to pause to check if there's any more questions. Looks like no, so I think we'll just progress on here. Oh yeah, and I don't have a ton of time, so I think it's good to keep moving. So scikit learn is the go-to machine learning library in Python, and it is a real gem. So scikit learn has this remarkable quality of being an all-in-one machine learning package. So there are lots of machine learning models that you might want to use, like linear regression, logistic regression, random forest, all these different models. In most programming languages, what you have to do is you have to go and fetch, you have to use a separate package for linear regression, and then you have to go and get a separate package for logistic regression, and then so on. Every single model, you have to go and get these separate packages. By contrast, scikit-learn has all of them in one place. So that's super beneficial because they all these models have the same interface. So if you want to switch out one model for another, it's really easy. You can just pull one out and stick a different one in its place and everything will still work. Contrast this with how things work in other languages and going from package to package, all the inputs are named different things. You're going to have to bend your code in all sorts of weird ways to make it work once you substitute a new model in its place. So having all of the machine learning models in one place, and they're all using the same interface, the same sort of usage pattern, it's really handy. It makes it less confusing to get started because everything's kind of uniform or standardized. So it's really nice to use. I don't know of any other programming language that has this kind of all-in-one package. And then just as a side note, the way they've sort of put out their documentation, their guides on the web, it's I thought I had an example of the website. Well, I would highly recommend checking out the SCI-KIT Learn website because they have very clean, well-documented guides on there. Okay. So training a model in SCI-KIT Learn, I think a lot of people have this idea that machine learning is going to be really complicated. Like you're going to have to write a lot of code, and your code is going to look like some Goodwill Hunting mathematical equation, right? Well, the thing is, if you're developing, if you're a PhD and you're developing some new machine learning algorithm, then yeah, you're going to have a lot of math in your code. But to apply machine learning models to a real problem and get work done, it's actually very little code. So this is all the code that goes into creating a linear regression model. I mean, a lot of this is very simple. So to create a basic linear regression model, that first line is just like creating a blank slate, a blank linear regression model. I'm specifying which columns I want to use to predict price. And then I'm calling model.fit to sort of train my linear regression model to go from those columns to the price that I'm trying to predict. And then finally, to use my model to go and sort of use this model to extrapolate and predict on new data, it's, again, just one line of code. So if you think the code is the hard part of machine learning, this is just a nice example of how, all right, you do need to know what's going on mathematically, but the actual typing, the actual writing of code is not that involved. This is what code that you would see sort of getting used in real life would look like. You wouldn't be building it from scratch. Sort of the same way that you wouldn't build your own bicycle or car from scratch. You wouldn't build these machine learning models from scratch just to be able to go and use them. Okay. So we're going to, I'm going to show a little bit of code for SCI-KIT Learn in a second here. And I'm just going to be using logistic regression. So to give a little bit of context here, I think everyone's heard of linear regression, right? Everyone's heard of linear regression where you fit a line to a bunch of data points. Logistic regression is sort of modifying linear regression to, instead of predicting a value, now we're going to shift to predicting classification. So in our data, we're looking at people on the Titanic. And so the model that I want to use is, or the model that I'm trying to develop here should output whether they survived or they didn't survive. So that's not outputting some number like 12, it's outputting some category. So logistic regression is sort of a modification of linear regression to this case where we need to predict a category rather than some specific number. Okay, so all right, I've got very little time. I don't want to run over. So let's first sort of showcase what we can do with matplotlib, and then I'll turn to SCI-KIT Learn. So matplotlib I think one of the main things that people, let me just hide the floating controls. Okay, so one of the main things that I think people get kind of wrong about building data visualizations is I think people tend to think that, okay, if I'm building a data visualization in Python, I'm going to have to hand code all the colors and all the details and things like that. And that's actually not quite true. So if I plot a bar chart, here I can plot a bar chart with really just one line of code. And granted, this is going to be a pretty, okay, so I can plot a bar chart with just one line of code here. And then if I want to make it a little prettier, I can add, so I can add a legend. I can sort of set what the ticks along the x-axis are and add a title. Maybe I want to set font size equals 20 just to make it a little bigger here. And maybe it's better to rotate the names of the towns people are coming in from. But I don't want people to think that it's terribly onerous to come up with a data visualization from Python code. So a lot of the work is done by this line here. So style.use Seaborn. There are a whole bunch of built-in styles that that Matplotlib has available. So you can really just pick through all these pre-built styles. You don't have to like know a lot of color theory and be good at design to create a good data visualization. You can just use some of these built-ins and maybe tweak it here and there where you want it to be a little different. Okay, so yeah, this is just an example of how quick it can be to build a data visualization in Python. So I wanted to give one more example, and this is using stock market data. So all of this is just pulling sort of a Apple stock data from a website. So we're pulling a CSV from the web, which has up to the minute. Well, I think it's updated up to the minute, and I have to have some sort of account with them just to show like, okay, I'm not just some random person on the internet trying to bring down your server. So okay, I have this data, so it's pulled into a data frame now, and now so what I get is this day by day. I get this day by day sort of showing me what Apple opened at, what the high price, what the low price, and what the closing price of the stock was. I can sort all of this. So I can say sort values. I'm going to sort it by date. And I just want to leave it. I don't want to create a new data frame by doing this. I just want to leave it as it is. So if I do that, I can do some really nice things once I have it sort of sorted like this. I can say, okay, please show me, all right, 2014 February to 2014 April, and it'll just filter down to February through April, right? And I can take the opening price, the closing price. I can create a visualization from just those, and it's really easy to, let's see, 2014-04. It's really easy to create, to sort of slice and dice your data, and then in a sort of programmatic way, turn those into visualizations. So I thought this was a good example of, again, like how you can do a lot with not a lot of Python code. So you can get a lot out and not have to write tons and tons of code. Okay, so I don't want to go too far over. now I want to show you guys sort of how a basic, sort of machine learning workflow would go. So here I have this data set. I have all these rows of data about people on the Titanic, but I'm gonna need to get rid of all the nulls, right? So I have a bunch of rows that have nulls. To get rid of those, I'm gonna have to do data frame.drop NA. So this is just dropping the nulls from my data set. I'm going to focus on gender, age, and passenger class as my sort of dependent variables that independent variables that I'm trying to predict from. And then I'm going to separate these into, okay, these are what I'm using to predict, and this is what I am trying to predict. So if I fit my model using this data, I'm now ready to go and use this. So I can say model.predict. And actually I can go and what I can do is I can put in my own information. So I can say, okay, I'm male, I'm 30, and I don't know, I don't have an actual ticket, so I can't say passenger class, but I've never bought first class in my life. So I'll just put 2 here. I can actually use my logistic regression model that I've just trained to predict whether I would make it or not on the Titanic. So I'll just run that. And what this is telling me is that I probably wouldn't make it off. What we can do is we could shift this and say predict proba, and this will show me the probability of making it off the ship. And so I could say, okay, so there's a 60% chance of no, but 40% chance of yes. So okay, it's close. Maybe I would have. It's not totally clear that I would have gone down with the ship. Finding the accuracy of your model is pretty easy. So we just do model.score. Okay, so this means it's only accurate on 79% of the passengers. It only got 79% of the passengers right. So that's also kind of reassuring. Like maybe there's just some error there. And then finally, just to give a peek at how we would go looking at kind of improving this model. So obviously we've sort of done the basics of building a model, but in real life, you're gonna have to go in and sort of work to improve your model to make it better. We can use what's called a confusion matrix. So a confusion matrix shows you, so along the rows, or along the row axis, this is showing you, okay, what was the actual outcome? So here, this is row 0, and so this is okay. People who didn't make it, and then the column number is what we actually guessed. So this spot here tells me, okay, they didn't make it. We correctly guessed that they wouldn't make it, and so we got 38 people correct with this model. Likewise, this is row 1, column 1. So I am sort of guessing correctly. These are people who we did think were going to survive. And since it's the first column, column 1, this is 105 people we got right. So here on this other diagonal, we have cases that we didn't get right. So 18 cases where they actually made it. We didn't think they were going to make it, or actually, sorry, people we thought were going to make it and who didn't. And then likewise, 21 people who we people who did make it that we didn't think were going to make it. Okay, so this is what you would kind of look at when you're starting to say, okay, I know my model performs this well, but how do I focus on fixing it? Like, so should I focus on the cases that I got wrong in this way, or should I focus on the cases that I got wrong in this other way? And this is sort of the starting point for figuring out how I can improve this model. Okay, so I'm way over time now, so I want to stop and sort of leave things where they are. If anybody has sort of questions that they'd like to ask at the end of this, please throw them in. I'm sort of watching the questions that are getting forwarded here. And if not, if we don't have any more questions, then I'll just say thank you, because I think it was really good. Yeah, really good that we were able to go through all of this, and I hope this was valuable. The first half for, again, being able to recognize the right time and place to use Python, and then secondly, sort of getting to know the main characters in the Python data science ecosystem. All right, so maybe I'll hold on for one more minute or so. If there aren't any more questions, okay. So any Python book recommendations? Oh, great. Yeah, so I can definitely recommend some resources here. So in some sense, it depends what you want to, it depends on what you want to learn. So I think a lot of people, I mean, the fact that you're tuning in probably means you're interested in using Python for data. I think the main place to go for that would be a place called dataschool.io. So Dataschool there's a ton of free material here. But specifically, if you're specifically interested in using Python for data science, I would start with the PANDAS material. So there's all sorts of crazy machine learning stuff you can do with with Python, but I think unless you get a foundation with PANDAS, you're going to waste a bunch of time just trying to sort of sort your data out and clean it, and you're going to end up reinventing the wheel there. So having a foundation with PANDAS is kind of really important. Also, I mean, if you're just trying to do data analysis, exploratory data analysis and visualization, PANDAS, I mean, just knowing PANDAS is enough to get plenty of jobs. So all of these resources here, they're going to be instructional videos. If I have one recommendation about the videos, I might watch them on, say, 1.25 or 1.5, just because the host does move a little bit slowly. I mean, I think it's good. You know, it's better than moving too quickly. But I do find it's a little easier to watch on a little higher speed. But they're visuals, I mean, they're videos that also have, and this is really nice, they also have all of the Jupyter notebooks that he uses throughout the videos are available to download. So you can get all of the code that he's using in his videos freely available. So that's really helpful, right? To be able to get all of the visuals. Yeah, so the slides from my, yeah, I can mail out, you know, any of the slides that I used. Let's see. I actually think I might already have a link set up for it. Data Noble desktop seminar. Nope. Okay. So no luck on the link. But yeah, I can either over email send the seminar PowerPoint, or I'll send out a link later. So if you request from Noble Desktop that you're interested in the slides, I'll just make sure to get those to you one way or another later. Oh yeah, so okay, I just talked about Dataschool. I think there's tons of really good free resources there. For practicing Python, Practicing Python, I think just the core language, I think there's a couple good resources. So I mean, starting out, I think you just use something like Code Academy to get the basic syntax down. So Code Academy, I believe you can still use Code Academy for free for basics. So it's the benefit here is that it's kind of interactive. It makes you code. Oh, that's too bad. So apparently you have to pay for most of this. But you could also use, but I don't know, I think it is worth it. I don't think it's that expensive. So I would use Code Academy or Learn Python the Hard Way. And then for practicing, I think CodingBat is a really good website. So CodingBat just has a lot of basic exercises to help with just practicing your basic Python syntax. The nice thing about CodingBat is that it actually runs tests over your answer and tells you, okay, for these inputs, you got the question right. For these inputs, you got the question wrong. And so it gives you some sort of incremental feedback on what you need to fix. There's also solutions available. So if you get stuck, you can at least figure out what you were missing. So I think this is for that core Python language material. I think this is a really good practice site. Yeah, let's see. Okay, final recommendation, and this is really more for yeah, getting into the more advanced data science stuff. There's a free textbook called Python Data Science Handbook. So Jake Vanderplas wrote it, and so the whole thing is available for free on his GitHub, and he goes, it's very high quality and right, like, I mean, amazing quality, and it's just available for free on the web. So this is not going to be as easy as watching videos from data school. This guy is, you know, getting into some pretty nitty-gritty stuff, but it is, I mean, if you master all the material in here, I mean, you're doing really well. I mean, that's definitely, you know, you're sort of ready for the job market for sure. Okay, so yeah, so I think that those are the resources that I would recommend. Data School for sort of pandas and getting started with data science. CodingBat for practicing your basic Python syntax, and then finally the Python Data Science Handbook when you want to get into the real nitty-gritty of data science. Okay, so I think we are out of questions at this point. So I think I will sort of end the meeting here, in the seminar here. I'm just dragging my feet a little bit to see if there are any more questions, but it looks like we're all done. So thanks everybody for tuning in, and I really appreciate you taking the time. Hopefully, if you're interested in this stuff, we have a few classes that. So the Python for Data Science class is a 30-hour course where we're going over sort of pandas, NumPy, the foundation of the Python data science ecosystem, going all the way up to using linear regression, covering visualization, getting that like solid skill set in data science. And then we also have a 3-day or a 18-hour machine learning course where we get more into sort of predictive modeling, doing random forest, logistic regression, this kind of thing. And as well as SQL. So we have a PostgreSQL class as part of, if you're really dedicated to this, a data science certificate. So depending on what you're interested in and what your goals are, I would highly recommend checking those out on the Noble Desktop site. I'm going to be teaching all of the data science related courses. So if you liked how this went, again, it's going to be more interactive, more exercise based in class. But I will be teaching it. So if you like this at all, I think that'll be sort of even better in class. So thank you. And if there are, yeah, okay. I think we don't have any more questions. So that'll be it for today.